Okay, so this will be the last section in Chapter 4 before the test, and it's an optional section. So this is going to be Section 4.10. Not every teacher will cover it, so sorry for getting the bonus coverage here. There are some things in Chapter 5 that just assume that you know just the very beginning of this section. So I made this section a little bit on the easy side. As a matter of fact, every problem in this section can be done on my calculator if I get it in the right mode. So in this section, we introduce a letter. Well, it's not introducing a letter, that's the letter I. But I in this section stands for imaginary. I don't know if I could spell imaginary right now. Sorry for any horrible spelling errors. I stands for an imaginary number. My calculator has an I right above the ENG key. I can't see that right now. Let me just blow this in. Hopefully I don't forget to do it. So my calculator has an I right above the ENG key. In order to get my calculator to do well in this section labeled complex numbers, I need to get my calculator in a new mode. And this mode you can leave your calculator in almost forever. We don't need to yank it out of this mode unless we're graphing. So I'm going to, having issues here, I'm going to get my calculator ready to work the problems in this section. And simply I turn my calculator on, I hit the mode button, and then I select option 2 that says complex. So I hit mode, and then I'm typing now the number 2. And you will see, hopefully on the top of my calculator, right there it says CMPLX, which means complex. And having your calculator in that mode, if you hit the ENG button, it starts giving you as many I's as you want to have. And I is the kind of the key to this section. So now we have a calculator, we hit the mode button, we hit option 2, we see complex on the top. It will do every problem. Wouldn't even have to lecture on this section if I didn't care to. I has an interesting property. The reason it's called an imaginary number is that when you square it, you get a negative number. Generally, when you square any number, you get a positive number. I has the property, so if I hit I, which is the NG button, and then the squared key, that's I squared, my calculator knows it's -1. This is why it's imaginary, because generally when you square any number, you get a positive number. And going backwards, if you square root of -1, you get an I. And I can do that on my calculator. If I square root of -1, when we're doing section 4.3, we were square rooting negatives and getting errors. If I had to put it in complex mode, my calculator would have told me the square root of every negative number has an I in it. So this is, in some sense, everything that makes section 4.10 makes up section 4.10. Everything else is just doing basic algebra with these facts. I stands for an imaginary number. I squared is -1. Square root of -1 is I. You'll notice that the section is titled complex numbers and not titled imaginary numbers. A complex number is a number without an I, which we'll call a real number, either plus or it could be a minus, an imaginary number. And any number that has an I after it's considered an imaginary number. So these would be examples of complex numbers. 3 plus 7i. It's a real number 3 plus an imaginary number 7i. 7i is imaginary because of the I. That's considered a complex number. Or maybe 1/2 minus 2/3 I. That would also be considered a complex number. The 1/2 being a number without an I is considered a real number. The minus 2/3 with an I is considered an imaginary number. And that's what a complex number looks like. We won't do anything interesting with complex numbers or imaginary numbers other than just some really basic algebra, because anything that's interesting is kind of well beyond the scope of the class. But imaginary numbers are their kind of their twin, I guess, or their combination part. Complex numbers, they're used a lot by engineers and scientists. For instance, if I wanted to, if I was like a neuroscientist and I wanted to create a model, maybe a computer model of how, this is a word I probably can't spell again, neurons, fire in a brain, the code is likely going to contain I. Heck, if I was an engineer and I want to predict how a road is going to wear out, especially one that has like a pothole in it, oh gosh, I can't spell deteriorate. That can't be spelled right. But anyways, if a road has a little pothole in it, as cars drive over it, their suspension, their tires start to vibrate kind of a bit, and it will cause the road to wear out further down, and that sort of computation is modeled with an I. And even for something that might be something you do daily, if you're driving in your car, texting, which you shouldn't be, I suppose, or talking on your cell phone, eventually you get close to one cell phone tower, and away from another cell phone tower, and the code that tells the code written in your cell phone that helps it decide when to switch from one tower to the next, that also has I's, or imaginary numbers, in it. So they're used everywhere, but their use is way complex, so we can't really show you how they're used. We just tell you that they are used, and you just have to believe it. And if you turn into an engineering major or a really high-level theoretical scientist, then you'll get to see more I's than you ever cared to. What we get to do with I, 100% of it can be done on our calculator, and even if we didn't have a calculator, it wouldn't be terribly hard. So generally, I's come up in problems that have square roots with negative signs under them. They don't come up for cube roots, fourth roots, fifth roots, or sixth roots. They are reserved for square roots. My calculator, now that's in the complex mode, if I entered square root and then typed the negative sign and typed 25, my calculator would tell me the square root of negative 25 is 5i. Basically, to do the square root of any negative number, you do the square root like it was a positive, and you attach an I to that number. So the square root of positive 25 is 5. The square root of negative 25 is 5i. Problem 4 wants me to go 5 times the square root of negative 49, which is going to be 5 times 7i. And algebraically, I'm going to treat an I just like it's an x unless I have an I squared. So basically, when we're working with I's, we treat an I just like an x, with the one exception that I squared will be replaced with negative 1. Whereas x squared can't be replaced with anything. But just by how I was constructed so that I, just like an x, I squared is negative 1. Square roots of negatives gives you I. So for this problem without my calculator, I'm going to treat the I just like an x. So 5 times 7i is a lot like 5 times 7x. And the answer to this, even without my calculator, I'll know will be 35i. On my calculator, I could have just entered 5 and then square root negative 49. And my calculator tells me I best get 35i for an answer. and when I look at the answer, I had 35i. So I can go through all of these problems without my calculator, or I can go with my calculator. For problem 6, it's a little bit trickier. I know that anytime I have a negative under a square root, that I could turn that negative positive if I put an I outside a square root. That's an answer, but it's not the answer to this problem because the square root of 54 can be simplified. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So the prime factoring for 54 is 2 times 3 times 3 times 3. And when I go to reduce, whether I have an I or I don't have an I, numbers under the square roots reduce the same, meaning if you have pairs, you get them out front, singles stay under and get multiplied. So in this problem, the 54 under the radical is going to break down so that I get a 3 in front of the radical for the pair of 3's, a 3 in front, a 6 under, and then an I after but not under the radical. I don't care at all if you would have just done this problem by going square root on your calculator, well, clear, square root, negative 54, and I just copy 3 square root of 6i. As long as the I isn't under the square root, that's correct. 8, if I was doing it by hand, the square root of negative 4 is 2i because the square root of 4 is 2, but the square root of any negative gets an I. Square root of negative 49 is going to be 7i. For now, I'm going to treat the I like the x. I'm going to multiply the 2 and the 7 and multiply the I and the I. This is going to give me 14i squared. So right now I'm treating the I like it's an x. But there's one exception with working algebra with I. If I get I squared, I can replace it with a negative 1. So this really is 14 times negative 1. And the answer to this, when I break out my calculator, is going to give me negative 14. I really have no issue with you doing every problem in this section on your calculator, especially as it's an optional section. So on my calculator, I would go square root negative 4, get out of the radical. I don't know if I need a times sign, but I'll put it in, and then do square root negative 49. And the answer is supposed to be negative 14. And you look at my answer, it's negative 14. For 10, let me do 10 on my calculator real quickly, and then I'll do it by hand. So 10, I'd go square root negative 3, get out, times square root negative 12, and I get an answer of negative 6. There's more or less an order of operations when you're dealing with negatives and square roots, and you have to get the negative into an I before you multiply. So this, I'm going to, by hand, write the first radical as square root of 3 times I, and the second radical I'm going to write as the square root of 12 times I. Then I'm going to multiply the square root of 3 and the square root of 12 together, and I'm going to multiply the I and the I together. The 3 and the 12 are both under the radical, so when I multiply them, I leave the number under the radical that they multiply to. The I and the I are both outside the radical, so when I multiply them, I'll leave them outside the radical. I'm getting close to my negative 6 because the square root of 36 is 6, and I squared can be replaced with a negative 1, so this is 6 times negative 1, which is negative 6. 12, I'll break my calculator out to do, so 12 is square root of negative 2 times square root of, square root of negative 6, and I get negative 2 square root of 3 for the answer that I'm trying to get. So on a test, I would make sure, even if I'm doing these by hand, to check on the calculator because they're easy to enter on your calculator. By hand, I'd have to go, first radical is the square root of 2 times I, the second radical is the square root of 6 times I, then I'd multiply the square root of 2 times the square root of 6, and I'd multiply the I and the I. The square root of 2 and the square root of 6 gives me square root of 12. I times I gives me I squared. And then I'd reduce the square root of 12. 12 is 3 times 4, 4 is 2 times 2. So 12 is 2 times 2 times 3, which is going to make it so I have a 2 in front of the radical and a 3 under the radical. So this is going to be 2 square root of 3, and then I squared I'm going to change to a negative 1. So that's 2 square root of 3 times negative 1. That's the same thing as negative 1 times 2 times the square root of 3. And the negative 1 times 2 that are outside the radical gives me the negative 2 that my calculator told me would be outside the radical. So hopefully, even the by hand isn't really intimidating. It looks, more impressive than it is to work with eyes. For 14, I'll do the same thing. I'll do my calculator first, and then I'll do it by hand. So 14 is the square root of negative 32 over the square root of negative 2. My answer is supposed to be 4. To get there, in the numerator, I'm going to make this the square root of 32 times I over the square root of 2 times I. And the i's are going to cancel because they're both outside the radical, and anything divided by itself is 1. So this breaks it down to the square root of 32 over the square root of 2. Both the 32 and 2 are under the radical, so I'll divide 32 divided by 2. I can do 32 divided by 2 without my calculator. 32 divided by 2 is 16. So this is going to reduce to the square root of 16, and the square root of 16 is 4. Get the answer for 16 fraction square root of negative 48 over square root of negative 6. The answer is supposed to be 2 square root of 2. And then I'll just show you how to get there by hand. By hand, I'm going to make the numerator the square root of 48 times I, the denominator the square root of 6 times I. Then I'm going to cancel the i's just like I did in the problem above it. That's going to reduce this to the square root of 48 over the square root of 6. Then I'm going to divide 48 by 6. And 48 divided by 6 is 8. And 8's going to be under the square root because both the 48 and the 6 are under the square root. Then I'll do a prime factor tree for 8. The prime factoring for 8 is 2 times 2 times 2, which tells me I get 1 2 out in front of the radical and another 2 under my radical, which is exactly what I saw from my calculator. 1 2 in front and 1 2 under the radical. $18 I could do on my calculator as well. 18 is just an addition problem. I'm going to treat the I like it's an X. Let me do it on my calculator just so you can see how easy it is for your calculator. So parentheses 4 minus 3I, the ENG button gives you the I, close my parentheses, plus parentheses 5 minus 7, ENG button gives me the I, close my parentheses. The answer is supposed to be 9 minus 10I. In this problem, I could, by hand, I can just drop the parentheses and go 4 minus 3I plus 5 minus 7I. Now I'm going to switch these because you can do that in an addition problem. Make this 4 plus 5 minus 3I minus 7I. The 4 plus 5 give me the 9. And then I'm going to treat the I just like it's an X. Because the numbers in front of the i's are both negative, I'll add the numbers and keep them negative and leave the I unchanged. It's only when you multiply do you start getting exponents. So when I'm adding or subtracting, the letter's exponent won't change, and that's why that's a minus 10I. For 20, I want to do it, parentheses 8 plus 9I minus parentheses 7 minus 9I. The answer is supposed to be 1 plus 18I. It's a little bit harder, but it's not really hard. First parentheses by hand I can just drop. Second parentheses, because there's a minus inside, I need the opposite. The opposite of positive 7 is negative 7. The opposite of negative 9 is positive 9, and you still need that I. Then I can rewrite this as 8 minus 7 plus 9i plus 9i. The 8 minus 7 gives me the 1 that my calculator gave me, and the 9i plus 9i gave me the 18i my calculator gave me. Ooh. 22s will be a little bit messier by hand, but it shouldn't be that hard. So parentheses 3 minus I parentheses minus parentheses 4 minus I, first two, then the last one minus parentheses 5 minus I. So I have the whole thing in there, but you can't see the whole thing anymore. And it tells me the answer is negative 6 plus I. I's are unlike x's. Usually when we have x's, we'd write the x first and the number second. When you have both a number and a letter, you generally write the I second. If you have a number and an I, you write the I second. By hand, I'm going to drop the first parentheses and write 3 minus I. I'm going to put the 1 that's implied in front of the I just because it might help me. Second parentheses, when I drop it, I need to put drop it parentheses, I need the opposite. The opposite of positive 4 is negative 4. The opposite of negative I is positive I. And again, I'm going to put a 1 in front of it. Next parentheses, when I drop it, there's a minus sign, so I need the opposite. The opposite of positive 5 is negative 5. The opposite of negative I is positive I. And I'll put the 1 in front of it. Now I'll group the numbers, 3 minus 4 and minus 5, and group the i's, minus 1i, plus 1i, and plus 1i. 3 minus 4 minus 5, if I was doing that by hand, I'd go 3 minus 4 is negative 1, negative 1 minus 5 is negative 6, and then these two i's cancel each other out because they're opposites, and I'm left with that 1i, which I could write the 1 if I want to. Get the answer for 24 first. 24 is negative 4i times 5i, and the answer is supposed to be just positive 20. This is multiplying monomials together. So to do this multiplication, I'm going to multiply the negative 4 and the positive 5, and I'm going to multiply the I and the I. The negative 4 times positive 5 multiplies to be negative 20. The I times I multiplies to be I squared. So this comes out to be negative 20 times negative 1, and the two negatives multiply out to be a positive, and you get your positive 20. For 26, I go I times negative 5i, and I get positive 5 for an answer. To do this by hand, this is I times negative 5i. I'm going to bring this I over here and write this as negative 5 times I times I. So I'll multiply those i's. I times I multiplies to be I squared, and I squared is a negative 1. So this is the same as negative 5 times negative 1, which is positive 5. For 28, I go 6i parentheses 5 plus 4i, and I get negative 24 plus 30i for my answer. Again, you'll see that when there's a piece number without an I and a number with an I, my calculator wants to put the I piece second because that's standard for whatever reason it is with I's. To do this by hand, I'd have to go 6i times 5 and 6i times 4i. For the 6i times 5, you have to multiply the 5 and the 6, and you leave the I alone, and you get a 30i. For the 6i times 4i, you multiply the 6 and the 4 and the I and the I. When you multiply the 6 and the 4, you get 24. When you multiply the I and the I, you get I squared. And then this is going to give me 30i plus 24 times negative 1. It would be okay to write 30i plus negative 24 for an answer, it would be okay to write 30i minus 24 for an answer, which is the same as 30i plus negative 24. But again, when you have an addition or subtraction problem that involves a number with an I and a number without an I, you usually write the I second. 30 is 6i times 2 minus I, and you get 6 plus 12i for an answer. By hand, I go 6i times 2 and 6i times, I'll say negative 1i because that I has an implied 1 in front of it. The first one, you just multiply the 2 and the 6 and you leave the I. That's the 12i part of the answer. And the other one, you multiply negative 1 times 6 and you multiply I times I. Negative 1 times 6 is negative 6. I times I is I squared. So this is 12i minus 6 times negative 1, which gives me 12 plus 6i because that double negative turns into a positive. I'd live with that, but you should be doing it on your calculator anyway, so that's the better way to write it. 32 is a foiling problem. And again, I'll just rip it out on my calculator as quick as I can. So I'm going to go 4 minus 3i times 5 plus 2i. And for my answer, I get 26 minus 7i. To do it by hand, it's foiling. Firsts are 4 times 5, which is 20. Outers are 4 times positive 2i, which is a positive 8i. Inners are minus 3i times 5, which is a minus 15i. Lasts are minus 3i times positive 2i. That's a minus 6i squared. That's not exactly where I need to be, but it's close. This piece right here, 8 minus 15i, that gives me the minus 7i part of my answer. The rest of my answer comes from taking the 20 and getting the minus 6i squared to be written without the I. So minus 6i squared, I'm going to make it minus 6, which is still there, and I squared I'm going to make negative 1. Then I have a double negative here, which is going to give me 20 minus 7i. That double negative gives me a 6, so what I have to do is go 20 plus 6 and minus 7i, and that's where we'll get the 26. '34 is a conjugate foiling, so when I do it by hand, I'm just going to do the firsts and the lasts. On my calculator, I'll just go 5 plus I, 5 minus I. My answer is 26 without an I even. So by hand, to be efficient, I should just do the firsts, 5 times 5, and the lasts, I times negative I. Because when you're multiplying conjugates, the same binomials in the parentheses with opposite signs, the outers and inners will cancel. The firsts comes out to 25. The last comes out to negative I squared. I'm going to change the minus I squared to minus negative 1. And that's going to give me a double negative, which I'll change to a positive. 36, when I do 6 minus I, delete I, quantity squared, I'm going to get 35 minus 12i for my answer. And 36, like 34 looks like it should be a foiling problem, but it wasn't. 36 doesn't look like a foiling problem, but it is. For 36 by hand, I have to rewrite this as 6 minus, I'll say 1i, times 6 minus 1i, so I'm writing it without the exponent, which means double multiplication. I'll do the firsts, which are 6 times 6. The outers are 6 times minus 1i, which is a minus 6i. The inners are minus 1i times 6, which is another minus 6i. And the lasts are minus 1i times minus 1i. That's a positive 1i squared, because negative 1 times negative 1 is positive 1. I times I is I squared. The outers and the inners have the same sign, so you add the numbers in front and keep the I, and you get 36 minus 12i for that. And then the plus 1i squared is going to be plus 1 times negative 1, because the I squared is negative 1. I can rewrite that as 36 minus 12i, either plus negative 1 or 36 minus 12i minus 1. They both are correct. Regardless of how you think of it, the 36 minus 1 or the 36 plus negative 1 give me the 35. I didn't copy my calculator's answer right. I forgot the 12. I wrote 2i, but my calculator's answer does have a 12i if I get it right there. So it should be 35 minus 12i. So if you're using your calculator, you got to copy it right from your calculator, or I can't give you partial credit. So if you did what I did and wrote 35 minus 2i and it was a 4-point question, you didn't show any of the work that I just showed, you'd probably lose the minus 4 points. However, if you did all this work and you wrote 35 minus 2i just because you did something silly, you're going to get partial credit, probably most of the partial credit, depending on how right your work is. 38 is 2 minus 3i squared, which is negative 5 minus 12i. 38 is also a foiling problem. To get there by hand, I'd rewrite this as 2 minus 3i times 2 minus 3i. Firsts are 2 times 2, which is 4. Outers are 2 times minus 3i, which is minus 6i. Inners are minus 3i times 2, which is minus 6i. And the lasts are minus 3i times minus 3i, and that's a plus 9i squared. The outers and the inners combine. They have the same sign, so they don't cancel. You keep the 6's, but you keep the i's and you add the 6's and you get a negative 12. The plus 9i squared is going to be plus 9 times negative 1, because the I squared is negative 1. I'll write this as 4 minus 12i minus 9, and the 4 minus 9 finishes out the problem to give me the minus 5 part. 44 plus 3i times 4 minus 3i is 25. And again, 40, when I'm doing it by hand, I'm going to be efficient because it's multiplying conjugates, and when you multiply conjugates, you just need the firsts and the lasts because the outers and the inners are going to cancel. The firsts are 4 times 4, which is 16. The lasts are 3i times minus 3i, which is minus 9i squared. That's going to be 16 minus 9 times negative 1, which is going to be 16 plus 9, which is 25. (42) and 44 are both conjugates as well, so I'm going to just by hand do the outers and the inners. On my calculator, I go 7 minus 2i times 7 plus 2i, and I get 53 for an answer. Let me just, since I have my calculator here, do 44 real quick. 3 minus I times 3 plus I, and I get 10. So I'll get those two answers by hand. For 42, I just need to do the firsts. 7 times 7, which is 49. The lasts, minus 2i times 2i is minus 4i squared. So this is going to be 49 minus 4 times negative 1, which is 49 plus 4. Sorry. And that's the 53. 44 is going to be 3 times 3, and then negative I times I. The 3 times 3 is 9. Negative I times I is negative I squared, which is going to be negative 1, because I squared is negative 1. You get a double negative, and you get your 10. So up through 44, the part at the beginning of reducing square roots with negatives, it comes up in chapter 5. The next problems also come up in chapter 5 when we do something called the quadratic formula. You might remember it, you don't need to know it now, but this negative b plus or minus the square root of b squared minus 4ac all over 2a, when you do some work with it, starts to produce problems that look like this that we need to reduce. And so I thought it would be a good time to just get used to reducing it, get to reducing it with my calculator and reducing it by hand. Sometimes my by hand answer and my calculator's answers look different, and that happens a lot when there's i's, and I'll accept the calculator answer and I'll accept the by hand answer, and I'll try to explain to you how they're the same. So for 46 on my calculator, I'd go fraction negative 6 plus square root of negative 81 over 2 times 3. And my calculator tells me the answer is negative 1 plus 3 halves I. I'll show you answers that are equally good, and I'll show you how to get the calculator answer. Completely content with that. If I was doing this by hand, on the first step in the numerator, I'd make the square root of negative 81 into 9i, because the square root of 81 is 9, but when you have a negative under a square root, you get an I. And the denominator is 2 times 3 is 6. If I was doing this without a calculator, at this point, I would take this negative 6, this 9, and this 6, and divide them all by 3. So my by hand answer is going to look different than my calculator's answer. And again, I'll take either. But my by hand answer is going to be negative 6 divided by 3 is negative 2. And then plus 9 divided by 3 is 3, and I leave the I. And then 6 divided by 3 is 2. That's my by hand answer. Completely good answer. If I wanted to get my calculator answer, then what I would have done, instead of dividing all these, I would have made two fractions up. The first fraction would have been negative 6 over 6, taking the left part of the numerator, writing it over the denominator. The second fraction would have a plus sign from this plus sign, and then 9i over 6. The negative 6 over 6 gives me the negative 1. The 9i over 6, when you reduce 9 divided by 3, you get 3. 6 divided by 3, you'd get 2. So this thing by hand, I'd get a negative 1 plus a 3i over 2. Anytime you don't have adding or subtracting in the numerator of a fraction, and there's a letter, you can bring the letter out to the right of the fraction, and they're equal to each other. So this by hand answer is just another way of expressing my calculator's answer. So there's 3 answers here. They're all correct for this problem. Again, I don't have any real strong preference other than this is probably what I would write for my answer, just because it's the way I normally reduce. I normally don't make one fraction into 2 fractions like my calculator does. So 48 by hand, I'm going to go fraction negative 8 minus the square root of negative 98 over 2 times 3. And my calculator's answer, oh my lord, is negative 4/3 minus 7 square root of 2 over 6 times I, which probably means another one of my by hand answers is going to be negative 4/3 minus 7 square root of 2i over 6. And my third calculator answer, my third by hand, this is a calculator only. This is probably what I'd get by hand if I was trying to emulate my calculator. My third answer that looks like this is going to have a 6 in the denominator because it will have the bigger of the denominators. And so let me write that in red just so it looks different. And let me try to show you how to get, I don't even know my by hand answer. I'm pretty sure I know it, but I'll try to get my by hand answer and then how to get that version of the calculator's answer. First thing I'm going to do is reduce the square root of negative 98. And I'm going to be cheating. I'm going to just do that in my calculator, but I could do it with a factor tree. The square root of negative 98 reduces to 7 square root of 2 times I. I could have done a factor tree and got that reduced, but I'm just not going to do that because it's not the important part of this. So by hand, I'd get the larger of the denominators. The larger of the denominators is 6, and I would write negative, do it in red, negative 8 minus 7 square root of 2I over 6. That's the by hand answer. The reason I didn't circle like I did in 46, in order to reduce it when you leave it as one fraction, the number to the left of the sign in the numerator, the number outside the radical in the numerator, and the number in the denominator all have to be divisible by the same number. In problem 46, the three things that I circled were all divisible by 3, so I divided them all by 3. In problem 48, 8, 7, and 6, the biggest number that each one is divisible by is 1. So if I was leaving it as one fraction, it's non-reducible. The denominator has to have the same. You have to divide all three things by the same number to leave it as one fraction. To make this as two fractions, like my calculator did, I'd go minus 8 over 6 minus 7 square root of 2 times I over 6. There's the 7 square root of 2 times I over 6. And this minus 8, 6, I'll go minus 8 divided by 2 is minus 4. 6 divided by 2 is 3. And that will lead me to the by hand answer with the I in the numerator. My calculator likes to shove the I out and write it in front of the fraction. So all three of these would be okay. You just have to be careful that and it's normal to leave by hand, leave this as one fraction rather than make it as two fractions. You can only reduce a single fraction when you don't break it into two fractions, if the denominator goes into both numbers outside the radical in the numerator. 50, I'll get some multiple answers going on here. For a test in this section, I don't really care if you just copy from your calculator, because again, we're not required to cover this anyways. So for 50, I get negative 3/8 minus the square root of 2 over 4I as my calculator answer, which means I can get negative 3/8 minus the square root of 2 times I over 4 for another non-calculator answer. And it also means that if I'm going to make it as a single fraction, which I had been writing in red, my denominator is going to be 8. It's going to be the bigger of these two. So by hand, I need to reduce the square root of negative 8. And the square root of negative 8 reduces to 2 radical 2I. So by hand, I'm going to make this negative 3 minus 2 radical 2I over 8. And even though the 2 and the 8 divide, which I can do if I'm making it into two fractions, if I'm leaving it as one fraction, this isn't reducible. As one fraction, it's going to be minus 3 minus 2 radical 2I. If you want to reduce the 2 with the 8, you have to leave the 3 and the 8 together. So this would be non-reducible as one fraction. But reducible if you leave it as two fractions. To get my calculator answer, I'd go, this is minus 3 over 8 minus 2 square root of 2I over 8. And then I can reduce this 2 with that 8. 2 divided by 2 would be 1. 8 divided by 2 would be 4. I don't need to write the 1, so in the numerator I'd have that radical 2I. The denominator I'd have a 4, and the first fraction has the negative 3/8. So because negative 3/8 needs to be part of my answer, if I leave it as one fraction, I can't reduce this because I need to keep the negative 3/8. It would be wrong if I wrote negative 3 minus 2 radical 2I, or radical 2I over 4, because I don't have my 3/8 anymore. All versions of the answers have the 3/8. This one has the 3/4. It's not good. Let me see. 52. 52, I'm going to go fraction 4 plus square root of negative 121 over 2 times 3. The answer is going to be either 2/3 plus 11 over 6i, or 2/3 plus 11i over 6, or by hand, my answer is going to be the bigger of the denominators, which is 6. So let me get this answer and that answer the best I can. By hand, the square root of 121 is 11, but because there's a negative, you get an I. The 2 times 3 is 6. The 6 does not go into the 11, so when you leave it as one fraction, you can't reduce it. So the one fraction answer, which is the easier answer to get, is 4 plus 11i over 6. The two fraction answers, you'd have to make this 4 over 6 plus 11i over 6. And then the 4 over 6, you go 4 divided by 2 is 2, 6 divided by 2 is 3. You get 2/3 plus 11i over 6. And again, my calculator doesn't like the I in the numerator of that fraction, and it drags it out front. So any of these would be okay, completely borrowing it from your calculator, doing it by hand and getting two fractions, doing it by hand and leaving it as one fraction. Always, if you're doing it by hand and leaving it as one fraction, the denominator you're going to get in your answer is the bigger denominator of your calculator answer. So I knew in the last problem, my denominator in my one fraction answer was going to be 8. My denominator in my one fraction answer for 11 was going to be 6, because it's always going to be the bigger denominator that your calculator gives you in the two fraction answer. Oh my. Tougher to enter, but I think I can do this. So 54 fraction negative 6 plus square root 3 squared minus 2 times 9 times 1 over 2 times 3. I think I'm getting all of this, not you can see all of it. So the best I could, I entered something that looked just like that. I see negative 6 plus 3 squared minus 2 times 9 times 1 over 2 times 3. And the answer is going to be negative 1 plus 1/2 I. That's pure calculator. By hand, I'm going to get negative 1 plus 1i over 2, or just negative 1 plus I over 2. And when I go to do this as a one fraction answer, the denominator has to be 2. There's got to be a lot more work. So all of these are going to be okay. That I could get by hand, that I can get by hand, that I stole from my calculator, don't have that yet. So for this problem, I'm going to work under that radical. 3 squared under the radical is 9, and then minus 2 times 9 times 1 is minus 18, and then 2 times 3 in the denominator is 6. So I did 9, 2 times 9 times 1 is 18. Now I'm going to reduce these. 9 minus 18 is negative 9, so I'm going to go negative 6 plus the square root of negative 9 over 6. It's the first square root I don't really need to drag my calculator out for, because the square root of 9 is generally 3, which I need an I. So this is going to be negative 6 plus 3i over 6. Calculator answer, I'm going to take this, this, and this, and divide them all by 3. Negative 6 divided by 3 is 2. 3 divided by 3 is 1. 6 divided by 3 is 2. So I'm going to get negative, it should be negative there, negative 2 plus 1i over 2 for my one fraction by hand answer. To get my calculator two fraction answer, I'm going to go negative 6 over 6 plus 3i over 6. The negative 6 over 6 gives me a negative 1, and that fraction is going to give me the I over 2, which you can write a 1 in front of the I, because the 3 and the 6 reduces to 1/2, and whether you do or don't have the 1 in front of the I kind of doesn't matter. All right. So 8, or 56, on my calculator hopefully where you can see my calculator, fraction negative 8 minus fraction 3 squared minus 5 squared over 2 times 3. And the answer I'm going to get is negative 4/3 minus 2/3 I, or negative 4/3 minus 2I over 3. When both the denominators are the same, I can tell you what my one fraction answer is. It's going to be negative 4 minus 2I over 3. That's what I'm going to get by hand. And I can only do that when the denominators are the same. When the denominators are different, I can't take my calculator's answer and back into a one fraction answer pretty quickly. So by hand, to get to this answer or to get to that answer, I'm going to go negative 8 minus the square root of 9 minus 25, because 3 squared is 9, 5 squared is 25, over 2 times 3, which is 6. Then under the radical, 9 minus 25 is negative 16. So I'm going to get negative 8 minus the square root of negative 16 over 6. The square root of 16 is generally 4 without a radical, but I pop a negative on because of the I. So I'll get negative 8 minus 4I over 6. And now this, and this are all reducible by 2. Negative 8 divided by 2 is negative 4. 4 divided by 2 is 2. That negative still stays with it. And 6 divided by 2 is 3. So you can see the negative 4, this is the 2I, and that's the 3 in my one fraction answer. To get my two fraction answer, I'd have to go negative 8 over 6, the unsimplified version of this, minus 4I over 6, and then 8 over 6 reduces by 2 to 4/3, and the negative stays there. This negative stays here, and this reduces by 2 to 2I over 3. And so again, my calculator answer with the I written to the right of the fraction, my two fraction by hand answer with the I in the numerator, or the one fraction answer that I get are all equally good. And again, usually I do things by hand, and that's the way you usually write it by hand. By hand, you usually don't make two separate fractions. Not sure why that is, but that's common. So 2 problems left, and let me handle 58 first. So 58, I go fraction negative, well, if I could do that, fraction negative 6 minus square root parentheses negative 5 squared minus 33 over 2 times 4. Oh, I don't know what the heck that is. I'm not feeling good about that. Let me hit the SD button. It's not really helping me out right here. So my calculator got stumped. And I don't want a decimal answer, so I'm going to leave my calculator and do it by hand. I was surprised that it got stumped like this, but it did. Let me try to enter it again and see if I get that same horrible answer. So fraction negative 6 minus square root parentheses negative 5 squared minus 33 over 2 times 4. Maybe I just entered something wrong. Ha-ha. I don't know what I did, but that was such a bizarre answer that I figured I messed up. So my calculator gives me negative 3/4 minus the square root of 2 over 4 times I. Since the denominators are the same, I can get my other by hand answers. My other by hand answer could be minus 3/4 minus the square root of 2I over 4, or minus 3 minus the square root of 2I over 4. All three of these answers are going to be completely fine. This was my calculator two fraction answer. That's probably what I get as a by hand two fraction answer. Easy enough to make my calculators. And this is the one fraction answer I'll get by hand. By hand, under the radical, negative 5 squared is positive 25. And that's going to give me negative 6 minus the square root of negative 8. over 8. And I'll sneak the square root of negative 8 out here. The square root of negative 8 is 2 square root of 2i. So I'm going to make this negative 6 minus 2 square root of 2i over 8. To get to this answer, I'm going to divide this by 2, that by 2, and that by 2. Negative 6 divided by 2 is going to give me negative 3. That's going to give me minus 1. That's going to give me 4. So you could see the minus 3. I don't need the minus 1. I just need the radical 2 times I. And you can see the 4. To get to that answer, I would have had to go negative 6 over 8 minus 2 square root of 2i over 8. For the 6 over 8, negative 6 divided by 2 is negative 3. 8 divided by 2 is the 4. And for this one, 2 divided by 2 is 1. I don't need to write the 1. 8 divided by 2 is 4. And that will take you to that answer. Last problem, I think. So 60, fraction negative 8 plus square root of 9 minus 27 over 2 times 3. And I get, calculator, negative 4/3 plus the square root of 2 over 2 times I. 1 by hand, 2 fraction answer. I'm going to get the I in the numerator. And then, I think my denominator and my 1 fraction answer is going to be 6 because these don't have a common denominator. The common denominator is 6. I think by hand, I'm going to get something over 6 in my 1 fraction. So let me try to get those. So I'll do it in red just so it stands out. In the numerator, 9 minus 27 is negative 18. The denominator is 6. The square root of negative 18 reduces to 3 square root of 2i. So I'm going to write negative 8 plus 3 square root of 2 times I. And the nice thing about the 1 fraction answer is you don't have to reduce them most of the time. This is not reducible because the 3, the 8, and the 6 don't have a common factor. So my 2 fraction answer is going to be negative 8 plus 3 square root of 2i over 6. To get to my answer that my calculator gave me, I'd take the negative 8 over 6 plus 3 square root of 2i over 6. The 8 over 6 will go 8 divided by 2 is negative 4. 6 divided by 2 is 3. There's the negative 4/3. And then 3 divided by 3 is 1. 6 divided by 3 is 2. And that's the square root of 2 over 2 times I. So this was going to be great practice for Chapter 5. In Chapter 5, in Section 5.3, I think it is, we do the quadratic formula and reduce a ton of radicals, and this is as complicated as it gets in Section 5.3. So having the back half of this Section 410 under your belt is going to make the transition into Chapter 5 a lot nicer than it would be if this stuff was new. So next thing you need to do after you perfect this section is do the review for Chapter 4, and then turn your homework in, watch the video for the Chapter 4 review, and then we'll do the test over Chapter 4, and hopefully that's another good test. And we're, I guess, halfway there. So we've done chapters P1, oh gosh, we're more than halfway there, P1, 2, and 4. We're 4 chapters done. We have 2 chapters left, Chapter 5 and Chapter 7. Chapter 7 is a really short chapter. So we have 1 medium-length chapter and then 1 short chapter, and then we're done for the semester. And that's just got to be a beautiful thing. All right, so as always, if you just, if my video really is horrible, let me know, and I can, address that, possibly re-record it if I get enough feedback that I just, choked on a video. And of course, if you're not understanding something that I'm doing, just please, visit me, and I've got ample time to help you, and I can maybe explain things better and differently to help you understand.